Good morning, boys and girls. We're here today to talk about the chemistry behind hot air balloons. Surprised whenever I tell them about how much chemistry is actually involved in the making of a hot air balloon. To start things off, you need the heat source, which in this case is candles. And my friend Stefen is an expert on that subject.
So propane is the main source of hot air balloons. The empirical formula is C3H8. The propane is pumped into a steel cylinder. The pressure increases due to the given amount of atoms pumped into the cylinder, and because the steel does not give out even with pressure. Pressure is the reason why the propane works. It wants to create an equal atmosphere inside and outside the cylinder, forcing the propane to escape. Why propane is used is because it burns at a high temperature, approximately 2400 degrees Celsius, 200 degrees hotter than hydrogen, and 400 degrees hotter than natural gas. It's used to create heat, which is then captured by the balloon, therefore causing the whole balloon to rise because of the hot air rises. The graph is a representation of at what temperature and pressure the propane ignites and when it's a solid or liquid. Propane is a slam dunk for hot air balloons.
Wow, wasn't that a fun and informative way to describe how propane adds to the chemistry of a hot air balloon? How the heat of the propane adds to the chemistry of a hot air balloon. My good friend Jacob will now talk to you about how the base and the actual balloon has chemistry embedded right in it.
When the pilot is turned on the balloon, the flame heats up the gases, and that causes it to expand, causing the balloon to float. As the flame continues to heat the gases expand and keep going away from each other, making it increase volume. And as the heat continues to heat up the gas, some of the gas escapes from the bottom since it expands. Even though some of it escapes, it still maintains its volume because of the gas expanding on the inside. When you want a balloon to fall down, you take away the heat and the gases cool down and continue to escape from the bottom, so it falls. Now, this balloon floats up and down because of buoyancy, and that's what causes stuff to float, like in liquids or in gas, against gravity. So when the pressure increases inside the balloon, it floats up against gravity, and you could see buoyancy like a duck floating on water, something like that.
Homer!
Home run!
So far, we know the chemistry behind the hot air balloon. We know the gas that is involved in it and how it moves up and down. But the one thing we don't know is how the wind affects it.
As you know, it's impossible to steal a hot air balloon. You must rely on the wind for the speed and the direction. But where does the wind come from? Wind is just air moving from areas of high pressure to low pressure. These pressure differences are created naturally by the unequal heating of the Earth's surface by the sun. Over cold areas, it's generally a higher pressure, and over warm areas, it's generally a lower pressure. This is due to the fact that air is denser when it is cold. As you go up in altitude, the air pressure differences are much greater, resulting in greater wind speeds and allows the hot air balloon to travel faster. The air pressure differences doesn't have to be great to produce wind. In fact, most everyday breezes are caused by less than 1% air pressure difference. However, in great storms like in tornadoes, the air pressure difference could be greater than 10%. This produces like over 200 mile/hour winds.
Go! So far, we know the chemistry behind each part of the hot air balloon. It's back. Now making a guest appearance is Mr. Fuzzy Nuts the cat. We know the chemistry behind each part of the hot air balloon. So now, it's time to make one. We tape the straws together and glue the candles to the straw. We then tape the bag on the ends of the straw so that there's a nice pocket of air that the candles could heat up. Making a hot air balloon that works is actually very difficult to do. It took a lot of scientific experimentation and a lot of trial and error, but eventually I figured out something that worked. As the candle heats up the air inside of the hot air balloon, the balloon will slowly begin to rise. Then once the air gets out of the candle, the balloon will slowly begin to fall because the air inside of the balloon is slowly coming back to surrounding air temperature.
That's the chemistry behind a hot air balloon.
So I move along a bit higher. I'll be up and away, cause they gon' judge me anyway. So whatever, I'll be up and away, cause in the end they'll judge me anyway. So whatever. I learned, I see the dreams I made, so I'm cooler now. I can take.
As the gas continues to heat up the gas. Oh wait, that.
Okay, as of now, we already know how the balloon goes up and down, and the gas that is involved in the balloon. So you might be thinking of all the other factors that are, like, causing the balloon to change. Well, since it's kind of chilly, I decided to put on a coat. And... Nope.
Not it.
Nah.
Keep the shit. Due to the uneven heating of the Earth's surface, over cold land masses, it's generally a higher pressure than over hot air masses. This is due to as you go up in altitude, the air pressure differences are much greater, resulting in greater wind speeds. This allows the hot air balloon to travel a lot faster. In addition,
Turned away from it all like a blind man.